ঠিক আছে। Okay. Okay class, Assalamu alaikum. So today I'm going to start the lecture Microprocessor Interfacing, lecture 1. Before starting our course, so we just want to ensure that we'll get to know the basics about the microprocessing unit. That's the core module of any kind of microcontroller, and the most familiar, the microcontroller is the Arduino board, and we are very much familiar with it basically in Bangladesh. It's not about the Bangladesh, it's all over the country. Okay, so before jump to the main section, let's introduce myself. This is Abu M. Fuad, who is right now the acting lecturer of University of Scholars at Department of Electronic Engineering. So from now I'm going to take this whole course as well as the lab, and I will try my best to to encourage you more to enhance with these topics and try to put something new in your knowledgeable area. Okay, so our first question that comes to everyone's mind: what is MCU? So you may watch a very common IC or design or chipset, something like that, as a logo into the PowerPoint slide. Basically, today's revolution is not entered just in a one day. It takes hours and hours, months and months, years after years, and after the hard dedications, finally we have found our ultimate chip, that is MCU. So that is, we can say that microprocessor. Okay, our course is microprocessor and interfacing. So interfacing, we'll let it know about the after session, maybe after the meet. Before that, we just need to clear the basic concept of MCU. So I would like to recommend some questions from you guys, or questions from your mind, that what is MCU and how can you conduct this MCU in your perspective, and how you may watch it. Okay, anyone from the desk want to answer this question, that what is MCU? Okay, anyone? I guess no one going to answer that. So it's a very common phenomenon as like the integrated circuit, and you may consider it a microcontroller, which is a very compact one, and the compact one is an integrated circuit that can control some particular inputs. Okay, so we are going to have some terms that is relevant to this course, like we make control. The first one is control, the second one is input, the third one is output, and how may we define the fourth one? Okay, the fourth one is a system. So here are some 3 or 4 parameters that you can define this term MCU. So in a nutshell, we can say MCU is basically a microcontroller unit where it's a compact integrated circuit that controls a specific function. Oh, I just forgot to add one term, that is function. Okay, so that allows a specific function for some particular purposes. Okay, that allows some specific function for particular purpose. Okay, let's take an example. First of all, here you can see that lots of lights right down there, and the AC is running right now. Behind the scenario, there's a TV, and my left, it's just a basic board, and I'm standing with a marker with a microphone. Okay, so what is these surroundings? I mean, why I have just justified these kind of items right now that is facing in front of me. Okay, so the lights are, I mean, enlighten the room right now. The board is just, what is EEE doing right now? He is just, I mean, sending some lights that is relevant to this function and that is conservative to your eyes. Here's some board where you can put your writing, and in front of me it is capturing the video. So overall, as a result, you can say it's a classroom where a teacher is teaching microprocessor or any kind of subject, EEE. Okay, you can say it's a subject about science or physics or chemistry, whatever it is. So overall, you can say it's a class. Okay, classes video. Before that, for the classes video, you have some parameters on your hand. Okay, so you have some parameters on your hand for a particular video, a class lecture, a class video. So I can define it very easily. For making or conducting a class video, you need some particular parameters. You need a marker, you need a laptop, you need a board, you need a TV, or what are the essentials you need? You probably know about that. So all this compact and all this sum in a result, you can say it's a class. But when it comes to a video, at that time you put a camera in front of me and you are recording all this stuff, and you'll put it to the server or website or Facebook or YouTube, wherever it is. Then you can say, okay, that's the lecture. That's today's lecture, that's the previous lecture. So I'm talking right now like this, or elaborating something just to explain the microprocessor in a nutshell or in the easiest way, just with these parameters or point outs. Okay, first one is control, second one is input, third one is output, fourth one is system, and fifth one is function. Before that, I will define you input, output, and function and system just within one diagram. Okay, let's say if I say f of x is equal to y is equal to 4x plus 5. How may you define it, or how may you execute this? Let's assume that x is equal to 2, x is equal to 3. You may put some values 2 or 3 or random numbers. It could be positive, it could be negative. Then, as a result, you can say that 4 times 2 is 8 plus 5 is equal to 13. And 4 times 3 is 12 plus 5 is equal to 17. So the value 13 and 17 is the exact value of y. Okay, so you have executed the value 13 from this 2, and you have executed the value 17 from this value 3. Okay, so the fun fact is you have done such a great thing, but you never know what you've done. Okay, how? So you put the value over there and you calculate that particular algorithm, and as a result you get some value as a result. As an output. So you have find out output. You put the value like 2 and 3 as an input, and where you have put the value for a particular line, for a particular equation, and you can say for a particular system. Okay, whenever you put that value to the system, and you can say the system execute the value as a function. So here comes the question, what is function? A function is a system where you will put some input, and as a result or as an output, you'll get gets some value according to the input, and the overall system you can say is a function. So you have already get to know about the input, about the output, about the system, and the function. So all this stuff is related to MCU. So we have get to know about the input, output, system, and function. How does it make sense when you are adding control to this microprocessor interfacing chapter, right? That's such a great question. That would be a great question, or it would be a very silly question. Whatever it is, let's say. Okay, let's see. So you are in a control system. I mean, you are in a control mode. How you can define it? You can define it like this: that if you change this equation, like it could be 5x plus 9, then you get some different output. So it could be a different function. So the total unit can be controlled by the user or by the system. So you have to add an additional unit that is called control unit. Okay, so how this control unit emphasize overall things, right? That would be a very, I mean, that obviously you should come to your mind that how this control system integrated with this such microprocessor. Okay, so I'm not getting it complicated. I'm just making it easier that we can get this stuff very like acceptable, right? Okay. Right now, if you get to know about the function, if you get to know about the control, like I'm just giving you just some amazing example. Like right now, I'm watching the lights, I'm watching TV, I'm watching you guys, and I have the board as well to the left side, and the camera, the video is taking me and the class as well. So I can say the system is all about in a control position. Like if I want to switch off the light, I will put a value to the light that is 0. And if I have to turn on the light, I will put a value like 1. So how this 1 and 0 is related to the system? Yes, obviously 1 means on and 0 means off. It's a very basic binary scenario that you have learned in your early school. But how does it make sense when it comes to a light or intensity? Is it come to your mind? How does it make sense? Like, okay, this light is just sending some value, let's assume, sending some value, and it has a great intensity, and it's just enlivened the whole classroom. Is it possible, like a goosebump or like a horror movie, it will spark like woo and woo, and make some boom light or make some dummy light and make some fresh light? Is this possible? Yes, obviously possible. How? That can be possible with some different values. I can say, sir, we have just explained 0 and 1. How can you distinguish the values in within 0 and 1? Is it something like 0.5? I mean, 0.5 or 0.7 something? No, that is not exactly correct. You will get to know another kind of value that is 0 to 55. 0 to 255. Okay, you may say, sir, I'm just familiar with this 0 and 1 system and this binary system, and apart from that, there's a very common name. It's like digital system. It's a digital system, you can say, it's a digital system. And 0 to 55, and it's like the system, you can say, analog. Okay, so you have get to know the two system. One is the digital and another one is the analog. So the analog part is you can vary some results. It's not binding within some 0 and 1 range. Okay, it has a very sophisticated values with a very good range is 0 to 5. So you can play with 256 numbers, right? So how we may play with 256 numbers? Okay, let's put some value to this light. You can say, sir, well, I will give 112 to this light, and how will the result? That's great. So if it comes to 0, then the lights are off. If the value is something like 255, then it will send the highest number, and that is equivalent to 1, and the room will be in full light. It's like the monsoon is happening right now. Okay, so that's the most concerning part, but it's not like that. It's very, very easy. whenever putting some value like 112, it will just have the intensity of the current position and the rooms little bit dim or darker than the previous phase. Okay, right now I can't put the value 1 or 2 because there is no MCU system, but there is no any microcontroller, there is no any Arduino board right there, so I can't find that. Let's assume. Okay, so right now we are just doing something. We are just putting some values 1 and 2, then it will get darker. You can say, sir, if I put the value like 50, how will the result? I mean, what will the result? The result will be more darker than the previous phase. So you can take some 3 phases picture, like the first one, the second one, third one, and you can see the clear images that how that differs from the values. So it depends on the values. And then you say, sir, why I can put the values right now? Because you have to put this value to the system that is controlled by a particular IC chip, and that microprocessor, that chipset is a controlling unit, overall controlling unit, and that unit is the microcontroller. Okay, so how we can define the microcontroller right now? So if I jump to the so basic or so familiar definition, is a microcontroller is a compact integrated circuit that controls a specific function in an embedded system. So you are now going to ask me a question that what is embedded system? Let's forget everything. Let's think about a system, a circuit, a board. It's something like that. You have calculator in your hand, your mobile phone. So ultimately, if you just open up your mobile, if you just break your the plastic external part of a calculator, you will see a green PCB board over there. So the IC or the transistors or the diodes, so what's the capacitor, what are the elements, I don't know exactly right now. So that elements will be put there very sophisticatedly and very organized way, and you can say that PCB board is equivalent to the embedded system. Ultimately, that embedded system, you can call that system as embedded system when there will be a particular controlling unit. So ultimately, you are emphasizing an integrated circuit and you are controlling a function that can control the other stuff as a parameter. So you can say, sir, you have given an example of light. How are we going to know about the AC, or how are we going to be more familiar with some basic example? Right now, I'm just continue right now. Let's say you are driving a car and you are sitting on a seat, and does it make any sense that you are just playing with 0 and 1? I mean, you start the car will be at its maximum speed, like move, and you are in Dhaka city right now, so definitely you are going to be accident. Okay, and we are going to the hospital right now. So it's not possible. You have the value of 1 and you have the maximum value and you have the value of 0, and you just stop the car. That's not possible. You drive slowly, you get very fast, you just change up the gear. Sometimes you have to stop your car when it's traffic signal, maybe it's neutral or parking, whatever it is. So there are different phases. Okay, so to control or to manipulate the phases, you have to be familiar with this unified value. Okay, so the ultimately man-made car or the car will be made as a prototype that should be controlled, and at that phase you need the MCU. And the most famous MCU that is familiar to all over the world is the Arduino board. So right now, maybe you are clear why this course is very much important as an electrical electronic engineer, because there's an integrated portion, there's a portion of microprocessor, there's a portion of integrated circuit, there's a portion of control system, and a portion of basic functions. Okay, so you have to know the system, you have to know the controlling unit, you have to know the function. So according to the various equation, you have some various purpose, and according to your input, you get some different kind of output. That's how MCU work, the sensor work, and the overall functions work. Okay, I am going to give you the most simplest example right now. That is just create you a goosebump. Okay, let's say right now I'm just providing a lecture. Okay, right now, and you are the students, and the AC is running at the top corner of my side. If I turn off the AC, what will happen? As it's 40 degrees Celsius almost, there's lots of humidity and you'll feel some warm. Why you are just feeling so much warm? Because there's a temperature difference, and you can feel your basically your skin or the ultimate organs can feel the heat, the warmth actually, isn't it? So as a result, what will happen? You will start to get sweating, isn't it? You will start to get sweating. So what the AC is what's the role of this AC? It just makes an environment, and it is just delivering some values to you that makes you cool. So as a result, there is no sweating that is going to be burst out from your hand, from the legs, or the other parts of your body. So the simplest example, you have to get some value according to the input. The input would be to the AC. The input would be to the outside, the warmth, the temperature. So according to the temperature, you'll get some value as a sweating, or how much you sweat. It depends upon the temperature. So the sweating, the functional thing that works to your body is your brain. Your brain puts some signals to these organs that okay, it's very, very hot right now. It's humidity around there, and you'll get very much sweating right now. So the brain put the signals to your organs, and they started wet, and you'll get oh man, my tongue ache. Okay, so that's the result. So ultimately, it's all about the function. You will get some input, and as a result, you will get some output, and the whole system is worked according to a particular processing unit, and that processing unit of your body is your brain. Okay, so ultimately, when you are going to control something, you need a brain. That's how a robot works. A robot will take and put that remote like this, and take this remote like this, and turn off the AC, or turn on the TV. Okay, how it works? Because it depends upon the purpose, it depends upon the input. If you put some input like this, press this remote, if you move your hand, if you move your legs, or if you move your other part of body, it's basically the output. How? Let's say I'm feeling very hot. So the brain puts some signals on my hand, and my hand started moving like this, and to the left side, and I will turn this hand right now and capture this remote like this way, and what I will do, I will take this remote and press the button actually. So that's how it works actually. So man's hand is a God blessing, it is Allah's blessing. Allah made your hand, made your cushion, made your joint, is like moreover, further better, 1,000 times better than any motors. So the robot is basically made by some significant DC motors, where you will put some motors over there. It will just, work as a function like this and this. You put some motors like there. You make this movement like this or this or this. There is another motor over there to ultimately turn off or squeeze the fingers. And to grab this, here are some small servo motors that will capture the ultimate remote. So these signals, these motors will start working depends upon the signal, and how this signal works, how this brain move your hand or send the signal to your hand that you have to move your hand like this way. It depends upon the humidity and the temperature. You are feeling the hotness, you are feeling the humidity, you are feeling the overall temperature. And according to the temperature, the brain is sending the signal to your hand, and that hand is going to capture the remote and press the AC on or higher or lower the temperature of the AC. Okay, that's the signal, that's how a Sophia works, that's how the most significant robots are working. So you have to put some inputs on him. It could be a language, it could be a sound, it could be any kind of signal. Okay, then it will process that what he is going to say about or what he is going to work on it. So it will process, and after the process, successfully processing, it will send the output organs, output motors, output lights, or whatever it is an output, a motor is output phenomenon, to execute some particular task. So I may offer you some significant examples as a result how these robots, microprocessor unit, microcontroller, the integrated circuit, and the functions, how it works. Again, you have to know about the functions, you know the systems, you have to control, and overall the MCU is work based on these equations of the inputs, and that's how it executes as well. And the inputs to robot or to a system is basically a sensor. Let's say a fire alarm sensor. It will get that kind of fire to the sensor can sense, oh man, it's a dam here. Maybe there is some fire or there is some breakdown over there, there is some burnout over there, and okay, I have to spray the what? The carbon monoxide, spray the water. So why I'm going to spray the water? Because it's just fire over there. So the sensor sense it, okay, there is fire over there, and what I have to do? I have to spray the water. I have to just open up the nozzle of the water. Okay, that can just go down, or say that's enlighten the fire from this spreading. Okay, so we have to do it. How they do it? The sensor will sense it, the processing unit will process it, and send the motors to open up the nozzles, send the motors to spray the ultimate firing area. And that's how you can close down your area with a particular MCU. So the most friendly MCU is the Arduino, and that's the most familiar board. So today we have just get to know the basic concept of the microprocessor unit. Why should we know this? Because as an electrical electronic engineer, you must need to find the solution, and that's the ultimate solution using the Arduino. Okay, so that's the end of today's lecture, and I just want to share with that one thing, that we will get some quizzes as a surprise test, and that test will just belong to the class lecture, and there will be no prepared date or some timeline, and you have to attend that quiz on that day, this day. There will be no something such a creativity or something like that. There will be some very much essential or regular classes, and the thing you will get to your on your board, and that's the ultimate question of the quiz. And the most fun fact is, I don't know when that quiz day will come. That could be any day. That quiz can be 1, 2, or 3, or 4. But it's a surprise test, so surprise should be as big as a surprise. Okay, so that's the end of today's class. And 0 and 40. So yeah, that's it. Thank you so much, and thanks to come and attend this interactive class. And the next lecture we'll get to know about the ultimate Arduino board and its ultimate unit. So thank you so much, and assalamu alaikum.